Okay, so let's talk about the Pythagorean theorem. So before we do that, let's do a little review. Right, here's a right triangle, and the letters are arbitrary, but normally the hypotenuse is C, and then the other sides are A and B. That doesn't have to be. So if theta is down here, right, the first part to realize is opposite of theta is A, adjacent is B, and hypotenuse is C. So sine is opposite over hypotenuse, so it's the ratio of A to C, right, the ratio of those two sides. Cosine is adjacent over hypotenuse, so the ratio of B over C, the ratio of those two sides. And then tan is opposite over adjacent, so the ratio of A divided by B. Okay. All right. So actually, let's hop into classic problem number one. All right. So the reason why we talked about this first is the trig ratios actually give us a relationship between the angle and two sides. So give me one angle and two sides, I can have a relationship. The question now becomes, what's the relationship between the three sides themselves? Forget the angle part. So if I have something like this, no angle, are these three sides related? That's the question. Okay, and it turns out it's a very nice little visual and simple kind of way to show their or develop their relationship. And what we do is let's copy this triangle four times. So I have the exact same triangle four times. And now what I'm going to do is I'm going to put these vertices together to form a special little figure. So form it like that. So you can see one, two, three, four. Those are my four triangles that are identical. And if I put them together this way, I actually form this square in the middle as well. And that's going to be the key, right? So let's do this. Let's first find the area of this square, but we're going to do it by finding the area of the four triangles and the area of the small square. So the area of triangles are simply just what, 1/2 base times height. Well, I have four of them. So the area of the triangles will be 4 times 1/2. And each one of these, the base is A, the height is B, right? And if you went the other way, here the base is B, the height is A. So no matter what, all of these blue triangles are going to be A times B. So 1/2 A times B. I have four of them. So the blue combined will have an area of 2A times B. Right? That was easy enough. Well, let's find the area of the small square. Right? So when I say small, I mean the red one. There's a large square on the outside. We're not going to do that one. Okay, so the area of the small square, what's area of a square? Base times height. And the base and the height are the same. It's all C. So this is C times C or C squared. And just as a, I don't know, an FYI, you can see area of a square or a rectangle is base times height. Area of a triangle is half of that because cut this in half. If you cut a square or a rectangle in half, you get a triangle, right? So that's why a triangle is 1/2 a square or a rectangle. Okay. All right. So I digress. Let's go here. So the area of the blue and the red put together can be expressed as 2ab plus c squared. Right. So that's the area of this whole entire thing. Well, let's ditch the colors and let's actually find the area of this big square by just doing these sides. Remember, each one of these sides was A and B and A and B. So if it's AB, the whole length is A plus B. So it's a square, so both sides are A plus B. So again, area of a square, base times height. Well, what's the base? A plus B. What's the height? A plus B. So now we need to multiply this together. So this is simply just distribution right or FOIL. So A times A is A squared, A times B is AB, B times A is BA. It's multiplication, so I can write BA or AB, and then B times B is B squared. Okay, and you'll see that's exactly what I did. A squared, AB, and then BA I wrote as AB because I already have one. And BA and AB are the same, right? It's 2 times 3 and 3 times 2. They're both 6. So AB and BA would be the same. And then lastly, B times B is B squared. All right, so what's the area of the square here? Well, add those up. The total area is going to be A squared plus 2AB plus B squared. So that represents the area of this big blue square. So I have the area of the red square with the triangles, and I have an area for the big blue, the whole thing, the big square. Well, these two have to be the same, right? It's the area of the exact same thing, so I can set them equal to one another. And you'll see if I do that, two ABs cancel out, right? Subtract two AB from both sides, they'll cancel each other out. So we just figured out that the relationship between the three sides of a right triangle is hypotenuse squared equals the sum of the sides squared. And that's it. So Pythagorean theorem is that, right? So the three sides of a right triangle, and I'm going to label my right triangle again, A, B, and C, is simply hypotenuse squared equals the sum of the sides squared. So hypotenuse here is C, so C squared equals A squared plus B squared, sum of the sides squared. All right, that's the Pythagorean theorem. And not all triangles are ABC, right? So that's why it's good to know this part. Pythagorean theorem is hypotenuse squared plus the sum of the sides squared. All right. Okay. So let's do a little problem here. I just want to find the value of x, right? I have a right triangle. So as soon as I know I have a right triangle, I know two things. My trig ratios are in play. So sine, cosine, tan, and Pythagorean theorem is now in play. So I have another little nugget I can use on right triangles. Well, what are we given? We're given three sides. In fact, we're given, if I'm going to call this A, it doesn't matter which one you call A or B, right? Because you're going to square them both and add them up. So I'm just going to call this one A, call this one B, and then my hypotenuse is C. So that does matter, right? So make sure you know this is the hypotenuse. So now Pythagorean theorem states that it's the hypotenuse squared, so x squared, plus the sum of the sides squared. So 2 squared plus 4 squared. Now I just do the algebra. Right, so 2 squared is 4, 4 squared is 16, 4 plus 16 is 20, and then square root both sides. Right, so I'll get x equals square root of 20. You can just do this in a calculator and get a decimal. It's nice though to be able to reduce fractions. So realize that square root of 20 is square root of 4 times square root of 5, and square root of 4 is 2. So that's why it's 2 rad 5. Right? Okay, but that's the idea. So I just use Pythagorean theorem, the relationship that deals with the relationship of the sides, to find the third side. There you go. Okay, so you want to stop this and complete class art problem number 2. Okay, let's do our last piece here. Let's put kind of this and everything we've done before kind of together now. Let's say I have a nice right triangle, and again, I'm going to use this general right triangle where I label the sides A and B and then the hypotenuse C. So let's say that this theta, oops, I didn't label it here, but there's a theta here, right? So I'm going to put theta. Actually, in this case, I can put theta wherever I want, so I shouldn't say that. So we just know that the angle, one of these two is 40 degrees, and the hypotenuse is 5. All right, so again, let's go through our things. What are we given? We're given an angle and a hypotenuse. So now we got to figure out what do we want to find, right? So we want to find either the adjacent or the opposite side, depending on where I put the theta, right? And you got to choose. So we got to find everything anyway. So you pick. For some reason, I decided that I want to do opposite, and I put the 40 degrees right down here. And again, you can put the 40 degrees up here if you want, right? It makes no difference. So I decided to put the 40 degrees as bottom left corner, and I decided that I want to do opposite. So now I have angle, hypotenuse, and opposite. So those three together are a sine. So sine of 40 would be opposite, which is B, all divided by hypotenuse, which is 5. So here is my equation, right? And now how do we isolate B? Well, multiply both sides by 5. So it'll be 5 sine 40. That's where I got that. And then 5 divided by 5 is just B. So B equals 5 sine 40. And then this is straight up calculator. So 5 times sine of 40 is 3.21. So now we know B is 3.21. So now what do we have? We have two sides and an angle. And so I don't know if this is either good or bad, but now we are loaded with options, right? So there are actually three ways we could figure this out, this A, right? So we could either use trig ratios or the Pythagorean theorem. It's up to you. I'm going to show you them all, so just so there's no confusion, I guess, or maybe it'll make it more confusing. Who knows? So I could do cosine because I have 40. I want are adjacent, and I have hypotenuse. So cosine of 40 is adjacent divided by hypotenuse. Multiply both sides by 5, and A is 5 cosine 40. So I can type that in the calculator and get a value. Well, I also have tangent because I have the opposite side. So tan of 40 is opposite divided by adjacent. So tan of 40 is opposite divided by adjacent. Now multiply both sides by A and divide both sides by tan 40. You'll get an A equals 3.21 divided by tan 40. All right, so the math works out that way, right? The A and the tan are going to switch. They just switch places. right? But again, mathematically, it's because we multiplied both sides by a and then divided both sides by tan 40. That's how it works out. Okay, well, there you go. I could have used a tan also. Or I could use Pythagorean theorem. So hypotenuse 5 squared equals side a squared plus side 3.21 squared. And now let's subtract over 3.21 squared to get a squared. Square root both sides, and there you go. So any one of these three, and I would suggest you do it. Calculate a with 5 cosine 40, 3.21 divided by tan 40, and then square root of 25 minus 3.21 squared, and see if all the a's are the same, right? And the a's should all come out to be 3.83. So once you get enough sides, you can pretty much do whatever you feel like. All right? Okay. All right, that's it for the video.